Welcome to solverfy.
All right, let's fill out this proof. So we know, as you should know, all proofs start by stating the given, and it says that segment GA bisects angle G, and segment GA is perpendicular to GD, which was broken apart. Notice the given as the reason in statement 3. So statement 3 must be the other part of the given. So I'm going to go ahead and fill that in now too. Segment GA is perpendicular to segment LD. By the definition of angle bisector, an angle bisector, it cuts an angle into two congruent parts. So if it's GA that's bisecting angle G, there's equal or congruent angles on each side of that segment. Give them names. The one on the left we could call angle LGA, for instance. And that would be congruent to the angle on the right that I've marked, which we could call angle DGA. So now we have some congruent angles. If GA and LD were perpendicular, then angle GAL and GAD would be right angles. That would be by the definition of what you were given here, perpendicular. I'm just going to use the symbol, but it's the definition of perpendicular. We know that all right angles are congruent, so we're talking about these angles being congruent to each other, because if they are both right, they are the same. They are congruent. And so now we have a second pair of congruent angles. We also know that GA is congruent to GA. You probably call that the reflexive property. Therefore, these triangles are congruent by two angles on the included side, angle, side, angle. And if the two triangles are congruent, then we can finally prove what it was out that we were set to do, that segment GL was congruent to segment GD, because those are parts of those congruent triangles. So if we can say that the whole triangles are congruent, these two segments are, or the parts are, you should be calling that CPCTC. The corresponding parts of congruent triangles are congruent.